Guided exercise number 7 says determine the following indefinite integrals using guess and check or using the table above. And so remember we talked about earlier that when you have a constant times a function, so like this 2 here and this 3 here, you can drag those constants and work out the indefinite integrals of the individual functions. And so in this case, we can do 2, and then the indefinite integral of e to the x is e to the x based on the table. And then minus 3, indefinite integral of secant squared of x is tangent of x. And then we need to put a plus c on the end. Now, if you were strictly going by the table, you might have said, well, this should be 2 times e to the x plus a constant, which I'll call c sub 1, and then minus 3 tangent of x plus some constant, which is probably a different constant, so call it c sub 2. But that's the same thing as 2 e to the x minus 3 tan of x, and then plus 2c sub 1 minus 3c sub 2. And so the idea here is this 2c sub 1 minus 3c sub 2 just represents a constant, some kind of constant. And so when we're using the table, instead of actually writing out the c sub 1 and the c sub 2, what we do is we just remember to tack one on at the very end of the problem, because we can dump all of our constants into that single one. So these are dumped together. Into the C that I wrote in my final answer. And don't forget, on every single one of these, you can check your answer by taking the derivative. So let's check. Let's take the derivative of 2 times e to the x minus 3 tangent of x. So we get 2 times e to the x and then minus 3 times secant squared of x. Okay, so we did it right. So that's part A. So from now on, I'm just going to write that plus c at the very end instead of doing these individual c sub 1 and c sub 2s. So that's part A. Part B, you have a lot of powers. And so what I want to do first is I want to rewrite this expression using a little bit more transparent version of these exponents. So this is really the indefinite integral of pi times x to the negative 1/2 power plus 17 x raised to the negative 4/3, and then minus 1/5, I can't really do much with that, 1 over square root of 1 minus x squared. And that's integrated with respect to x. And so again, we'll do the thing where we drag the constants and we determine the indefinite integrals of the things that the constants are being multiplied by. So again, we're using a constant multiple rule for indefinite integrals. And that works anytime you have a constant times a function. So we'll do pi, and then when we do the indefinite integral or anti-differentiate x to the negative 1/2, we get 2 times x to the positive 1/2 because of the power rule for indefinite integrals, plus 17. Okay, so let's do some scratch work here. Negative 4/3 plus 1 is negative 1/3. And so our new exponent is going to be negative 1/3. And what's supposed to go in front, according to the power rule, is your new exponent, but flipped. And so that actually becomes a negative 3 when you flip it. And then minus 1/5, and I'll use arc sine of x. And then plus c. And we could do a little bit here in that we could multiply the 17 and the negative 3 and the pi and the 2, but that's fine. And so, again, what you should do is mentally check. So if I have 2 pi and then 1/2 x to the negative 1/2, okay, my first term is right. Second term, I'm going to do 17 times negative 3 times negative 1/3 x to the negative 4/3. Okay, that's right. And then the third term, minus 1/5, 1 over root 1 minus x squared. Okay, so I did that verbally. Do it on your paper if you have room. It's kind of hard to write on my iPad really small, but that checks out. All right, so same idea, but on part C. So when we do the indefinite integral of 2 to the t, it's 1 over natural log of 2 times 2 to the t. Did you notice our variable changed? Make sure that you wrote 2 to the t and not 2 to the x. Minus, and then 3, when I do the indefinite integral of sine of t, I get negative cosine of t. And then don't forget your plus c on the end. And so this is the same thing as 1 over natural log of 2 times 2 to the t plus 3 cosine of t, and then plus c. And again, at least in your head, you should double check that you get what you're supposed to when you take the derivative. Be extra careful when you're anti-differentiating or doing the indefinite integral of a sine or a cosine. So that's part C. Part D. There's something a little weird going on part D in that you've got this x that's being multiplied by this other stuff. And you might try to come up with a way to anti-differentiate or to do the indefinite integral in terms of like having this x here and then having the 7 minus 1 over x squared. But ultimately, what you need to do to be able to get started, to be able to get an answer that you can check and it'll work out, is you need to distribute that x. You really just need to. So this is the same thing as the indefinite integral of 7x minus 1 over x dx. So again, drag the 7. This x is x to the first. So when you use the power rule for indefinite integrals, you're going to get 1/2 x squared for that part. And then minus, and remember that when you're anti-differentiating 1 over x, you have a different rule, not the power rule, and you get natural log absolute value of x, and then plus c. And then you can check, at least mentally, that when you take the derivative of this, you get what you're supposed to. And it works. Part E is the indefinite integral of e to the 3x plus 8 over 5th root of x to the 9th with respect to x. So let's go ahead and rewrite that exponent. This is the same thing as e to the 3x plus 8 x raised to the negative 9/5 power. And let's go ahead and do a little bit of scratch work. Negative 9/5 plus 1. 1 is 5/5, so that's negative 4/5. Okay. Now, if we want a function, we're going to have to use a little bit of guess and check on this one. If we want a function whose derivative is e to the 3x, well, it better be something like e to the 3x. But when we take the derivative of e to the 3x, we get 3 e to the 3x, which is not exactly right. So to fix it, we need to multiply by a 1/3. You can check that when you take the derivative of 1/3 times e to the 3x, you get e to the 3x. So that part is taken care of. Plus 8, and now do the power rule. So your new exponent is going to be a negative 4/5. And what ends up going out in front is the reciprocal of that, which is negative 5/4. And then don't forget your plus c. That negative is a little bit hard to read there. Now, if you wanted to, you could multiply the 8 and the negative 5/4, but you don't really have to. And again, at least in your head, you should double check that what you want to happen does happen. And it does. All right.